Nomenclature and symbols, by no means an exhaustive list. The first thing to consider is the congruency symbol, which looks like this. It's an equal sign with an extra bar. For example, x squared plus 5x plus 6 is identical or congruent to x plus 2, x plus 3. And that's because this statement is true for any value of x. Therefore, the statement is an example of an identity. Just to indicate that, let's say we take x equals 2. The left-hand side, usually abbreviated to LHS, would be 2 squared plus 5 times 2 plus 6, which is 4 plus 10 plus 6, which gives us 20. Now think about the right-hand side. The right-hand side, if x is 2, would be equal to, and I do mean equals with all of these, 2 plus 2, 2 plus 3, which is 4 times 5, which is 20. And this would hold for any value of x. And that's why we say it's an identity. That distinguishes it from an equation like 2x plus 3 equals 7, which is only true for one value of x, i.e. when x is equal to 2. A polynomial is a statement of the form p of x is equal to a0 plus a1x plus a2x2 plus a3x3, and so on. All of the various a's here, as I say below, and I'll repeat that in a moment, are just constants. An example would be qx, which is 3 minus 4x squared. This is an example of a polynomial. This one is a quadratic. In this one, the a0 is equal to 3, the a2 is equal to negative 4, and all of the other a's, a1, a3, and so on going up, are all 0, and that's why we don't write down those terms. So as said before, the various a values are known as coefficients, and they're just constants in front of the x's. All of the indices in a polynomial must be non-negative integers. So if you think about the a0, that's really a0 x to the 0, but we know that x to the 0 is 1. And all of the other powers, 1, 2, 3, are all positive integers. Some common symbols used when doing proofs are this double-barred arrow to the right, this double-barred arrow to the left, and the one that points in both directions. If we have a statement that says A and then the arrow and then B, that means that statement A implies statement B. So the arrow here is the implies symbol. The arrow going back the other way just means that statement B implies statement A. When we use the double-headed arrow, that means that statement A implies statement B, and that statement B implies statement A. This is known as an if and only if, and that's often written as just IFF. Please note that this symbol should be used when solving equations. For example, 2x plus 3 equals 7. It implies in both directions then that 2x is equal to 4, which implies in both directions that x is equal to 2. So that works going this way, but it also works going the other way, which is why you should use the double-headed arrow. However, when solving an equation like this, it's very often done by just using the single-headed arrow. So 2x plus 3 equals 7 implies 2x equals 4 implies x equals 2. It's unlikely that you're going to get pinged for that unless you're working specifically in this topic area. And indeed, I think you'll find that most people just use the single-headed arrow if they're solving an equation, just to show the direction that they're working in.